Well, good morning, everybody. Welcome to our webinar on safe and stable operations of Central Dedusting Systems. I'm Bas van der Bogen, and I'm here with my colleague Martin Turker, Head of Operations, who will be working on this webinar together with myself. Quite some attendance from various industries, fast-moving consumer goods, pharmaceuticals, and also the chemical industry, which is great. Would like to share a poll addressing what is your main challenges. So let me share it. And the outcome of our poll, we will use twofold, either in this topic, if applicable. Most of the challenges hopefully are, and if not, we will surely use it for future webinars. Let me share the poll. So what's the current challenge working on your site, if applicable? We have incorporated several challenges, and of course there's also some room to mention other, and you will share the poll results afterwards, so much appreciated. So why this topic of central dedusting systems making safe and stable operations? Of course, it's crucial to increase protection and reduce risks. And of course, it's crucial to safely connect the various pieces of equipment if applicable. And last but not least, CAPEX and OPEX involved from various angles is also crucial. So let's see if, okay, we have, let me share the poll. Hopefully everybody give their input. And okay, so explosion safety is the big winner with 42%, energy reduction 28%, and creating healthy work environment and improving economics both have 14%. So Martin, this is surely something you can work with. So let me give the floor to you, and yeah.
Well, thank you very much, Bas, for your introduction, and thank you all for attending to this webinar. As explained already by Bas, today we will be talking about central dedusting systems. And the central is important in this respect because there are some specific parameters which have to be kept in mind when we are talking about central systems. Today, main topics are, for example, reliability of the systems. You are all users of the system. It's not your aim to have a nice dedusting system operational. No, you would like to produce your goods, and the dedusting system is one of the needs to do it in a safe and in a clean way. Safety is an important topic here. Explosion safety mainly. And performance. How are the systems performing efficiently? Can we reduce, for example, also on CAPEX or on operational expenditure, energy consumption, for example? So those topics will be addressed within this webinar. First step, which we always do, is data collection. We see this as a very important step in designing a system. It might be a new system or an upgrade of an existing system. We work with both, as many of you might know already. So identification of the sources is very important. And you might already have existing systems, which is a good base to find the sources, but also we can come out to measure all the dust concentrations. Personal sampling for the operators can be something. And during those data collection phases also, over extractions and those kind of things will be identified as much as possible. We will be looking into your sites. How is it? How is the layout for your site? Do you, for example, have a draft doors which might be opening, which have influence on the air streams inside the factory? Those are important input parameters. And How's your process working? We are really looking from your process. Do we, for example, see an impact on the dedusting systems during startup or process interruptions? Might the dust input just be zero, or maybe be very high? And if so, do we have this to incorporate into the design of the system? So the data collection, the measurement programs are an important first step. During this step, we're also looking into what kind of systems are we extracting, or where are the exposure from the, where is the exposure from the operators? Are we working with open equipment, for example, hatches which are opened and dust might come out, and we of course can solve that by extraction hoods? Or are we talking about enclosed equipment, such as, for example, bucket elevators, and they might look the same, dust is coming off, but in terms of safety, they have to be addressed a little bit differently, especially with central dedusting systems. Or are we handling production equipment with internal fans? Basically, what we're seeing here is an example of cigarette makers. They have internal fans. They are self-supporting machines, and the dedusting system just have to take away the air with the dust out. But those machines are starting and stopping independently, and we have to make sure that there is no disbalance in the system. So all those kind of parameters are very important in the design of the system. And of course, what are we extracting? What can we expect from your process? What type of dust do we have to handle? For example, hygroscopic dust, which might mean that we have to maintain the relative humidity in your systems below 40 or 50%, for example. How is the product behaving inside the pipes and inside the filters? So we will be analyzing the particle characteristics, and based on that also determining what are the optimal conveyance velocity to, on one side, make sure that there will not be any sediment or minimum amount of sediment of the dust inside the pipe, but on the other hand, also know wear or not too much wear of the piping if we go into too high velocities. So here the particle characteristics are important, but they are also important if we are looking into the explosion and the fire characteristics. What are, for example, the KST values and the ignition energy needed to create an explosion? And are we talking about a mixture of the dust, or is it just a single product? What we often see in the processes, that if we are talking about mixture of the dust, that, for example, some of the additives have very high KST values, but the bulk of the product has much less. So do we have to design the systems for the very high KST values and maybe low ME values of one or two of the products, which is less than 1% of the throughput of the plant? Or can we, for example, be looking at a mixture of the dust, which can be beneficial when we are designing the system, and in the end of the day, of course, the CapEx. So it's important to really focus and get clear what is your process doing, what can we expect, and from there we will be designing the system.
Martin, I got a question of regarding bridging. Can you elaborate?
Yeah, bridging is an effect what might easily happen inside the dust collectors. We are collecting the dust, and then they are filtered out in the dust collectors. And underneath you have the hopper, for example, and some products which have an easy bridging, they need very steep angles, for example, or might even better work with a round hopper instead of a square hopper. So it's an important parameter to design the equipment and to prevent. Well, it's basically also going back to the reliability of the system.
Perfect, thank you.
Today we're talking about extraction systems and extraction of the indoor emissions. That's on this slide. It's the middle. But as a company, we are always having a holistic view. And if it's possible to eliminate the sources from the process, it's always beneficial to do so. So we will always be thinking with you to look into your process to see, well, why are there emissions? Can those emissions be eliminated? Because elimination of the sources typically is the best solution, because it leads to less pollution of your plant, which means maybe can mean also less ATEX zoning, less housekeeping and less exposure. And just an example here, in one of the processes which was working under atmospheric conditions in a room, we've been able, together with the customer, to bring the process to a slightly negative pressure, and due to that, the emission of dust from the process was already eliminated by 90%, and the remaining amount was extracted. So source elimination always is important to include into the design. Well, once we go into the extraction system, we always will be trying to have as much as possible product saving. If it's of course not your goal to get rid of the dust from your product, that can be the case. But if that's not needed, then we will be trying to keep as much as possible dust inside your process, which means more kilograms of your product and less weight. We are using deflector and degrader technologies for that. Example, what's shown here is of degrader hoods on conveyor belts. And the last one, if the operator exposure might still be too high after an efficient extraction system, we can be looking into dilution of the area. So we have a source extraction with, for example, 95% efficiency, and the residual dust will be diluted by ventilation. For example, we are using low induction jets for that. It's not today's topic, but I just wanted to show that as a company, we are looking holistically into this, into the systems and into your plans. Once we have collected all the data and we have, I would say, detailed discussions with your operations as well, to really understand what are the needs and what are also the constraints in terms of the system, we will be preparing extraction point lists to have clear overview, well, what has to be extracted, and designing the extraction capacities and the right extraction types. Once we have this, all of this will be translated into the air technical model. So we will make a model of your complete dedusting system with all physical parameters involved. That's also something you're seeing here on the left-hand side. All parameters like pressures, velocities, but also entropies, product amounts, etc., are entered into the system to get a clear overview what's happening in the system and where can there, for example, be bottlenecks. We are using this tool also very often when we are working with upgrade of the systems, and we say, well, maybe we can reuse 80% of the piping if you take care, or if you or we, or but if 20% of the piping is upgraded. And from this model, we also will be looking into the balance of the system. And typically, we are using balancing restrictors there. In the dedusting systems, we don't like the manual valve so much. The nice thing about valves is you can adjust your flow rates. However, on the other hand, one operator might think, you know, today I need a little bit more extraction on my process. So he's opening the flap, with as a consequence that the neighboring processes get a little bit less air. And over time, this might lead to a disbalance of the system and plugging of the pipes, because we talked already a little bit about the critical velocities inside your system. And once you start changing the velocities from the extraction points, this will have an effect, of course, in the headers of the system, and we have to avoid that. Once we have an overview and a technical model of the system, we will be making a 3D plant layout of the system. So a complete overview of what is planned and what will be installed will be made. And on this moment, we also typically have close interaction with your operators to really look into, well, can you work with it? Is it ergonomic for you? Because what we know from basically from every system, if the operators don't want to work with the system, it has a very negative effect on the performance overall. You can build perfect equipment, very nice piping layout, but if it's at the indoor emission source, if it's not correct, or if the operators don't want to work with it, it will break your system. So this is a very important step. And this can, for example, be during a pre-engineering study, but also during the detail engineering phase. It will be reviewed, and we will typically address you actively to involve the operations who have to work with the system. And from there, also the pipes, the hoods, the fans will be selected. The extraction sources, the extraction hoods are very important here. We talked already a little bit about the deflector hoods. An example is shown here of one of the hoods due to its special shape and the internal cone inside the hood, the internal deflector. The product gets the opportunity to fall back into the process. Typically, this is applied for applications where you have an hopper feeding a process below, which is non-continuously. We call it pressureless extraction, so it has multiple benefits. First of all, of course, extraction of the process and making sure no emissions to the environment, and due to that, less housekeeping, less ATEX zoning, for example, and well, no operator exposure. For other processes, this might not be the correct solution. And for example, we started the meeting where we had processes with internal fans, and there we just have to take care that the capacities which is given by the process are properly taken away, and there is no any influence of neighboring machines when a process is starting and stopping. And that's where we typically apply a carousel. And today we're talking about the central systems, and what we are learning more and more, that in many of the plants, not all processes are running at the same time. If we are looking into a central system, the typical approach is, well, we have to be able to extract all the processes at the same time, because we have to be within the VO crit range, within the critical conveyance velocity in the header. With a carousel, this can be avoided, because basically what the carousel does, it's a complete disconnection between your central system and let's say the local processing equipment. And if you have, for example, 10 production machines, but only 5 are operating simultaneously, the carousel makes sure that the right capacities is given to the right machines, and from there on, let's say downstream the carousel towards the fan and the dust collector, we can work with a smaller header, with a smaller main pipe. So it also has it has basically 2 benefits. First of all, a balancing of the system and making sure that different process scenarios can be handled well. And secondly, it also gives an opportunity for equipment size reduction, and energy saving. We talked a lot about the dedusting systems. We talked a lot about the extraction points and about how to connect them, how to balance it. But there is one specific parameter which is important in especially the larger central systems, and when we are interconnecting equipment, and that's, let's say, the overall explosion safe design. In the next slide, we will be addressing the explosion protection of the dust collectors, for example, but there is something in between, and that's mainly the piping network, and how are we making sure that the different process steps are safely connected. And effects which might happen in central systems are, for example, pressure piling. In one part of the process, you can have an explosion which leads to an ignition into let's say, the main pipes of the system, and from there the explosion gets the opportunity to accelerate and to become more intense. Flame fronts occur, and we get pressure piling, and those two effects are risky for the dedusting system downstream. They might, for example, lead to a higher initial pressure inside the dust collector, and this higher pressure will act as a multiplier to the P max of your explosion. So, for example, a common used design approach is that the dedusting equipment will be built for a P red of 0.5 bar. So we have, for example, explosion venting on it. But if you have an increased pressure when you have a starting explosion inside the dust collector, you have to multiply it. So this 0.5 might not be sufficient, together with the effect of a flame front, which will lead to a much more intensive explosion inside the system. So we have to take care of that. And we have to protect the different processes and the dust collector from each other. Let's say it like that. So this might mean that along the way we already have explosion venting, for example, by means of explosion diverters. And this is what we are seeing in central system is quite often neglected. So a very important point, because otherwise an explosion really might be destructive, and it's unexpected, because everyone might think, but we've got explosion, or we've got ATEX compliant equipment or NFPA compliant equipment, and why does this effect happen? So very important to keep in mind the overall system design, and how is not only the plant isolated from the filter, but also how is the filter isolated from the equipment.
We've got a question. You mentioned the under pressure. Question: is it then completely equal from maker to maker?
No. If I think you're going back to the carousel design, yeah. And from the carousel we are again balancing the lines. So the carousel basically is a central unit. It has a central position in the plant, and depending, for example, on the length of the pipe, on the pipe sizing, they will be balancing inside the pipe. So different sizes, different equipments can be connected to it.
Perfect.
I hope this answers your question.
Yeah.
So if we are looking into the dedusting equipment, we have different types. I think many of you will recognize the picture on the left with the venting and the isolation. It's a very common approach, but what we are seeing more and more, especially with the larger central system, if we're talking, let's say, roughly over 40,000 cubic meter per hour systems, chemical suppression might be the better option, because many of the components, for example, to isolate the plant or the equipment, are not available anymore in the larger sizes. So then a chemical suppression system might be a better option. If we compare the two, the venting is a passive system, suppression is an active system, and you can both do the suppression of the explosion, but also the isolation of the equipment. Another approach would be to have a pressure shock resistant system. This is something we are seeing more with let's say directly connected production equipment. And basically, what we are doing here, we are building the equipment so strong that it can withhold the explosion pressure. So it's strong enough to withhold the Pmax of the product we are handling, for example, 9 or 10 bars. With the larger systems, that's not the most common approach, as you say. And maybe one thing which is a little bit less common, but can be a very good solution in some cases, is to work with the wet scrubber. Typically, it's the case if you have dry waste, dry dust, keep it dry, because it's easier in terms of handling of your waste, or maybe you will be able to reuse from the process. But in some processes, it's possible to reuse a stream of water with the particulates, with the product inside, and then a scrubber could be a good option, because when the air loaded with dust enters the system, it will be completely wetted. There are no any dust clouds, and due to that, there's also no risk for explosion. So that's a completely different approach to also handle safely the dust from the process. And as a last slide, some examples of proven results. What we often see is that people are thinking, if we have an improved dedusting system, we have less or we have more waste, because we want to get rid of the dust from the process. We don't want to expose the operators anymore. We would like to have less explosion zoning, for example. So this will mean for me, I will have more dust. But this is for sure not in all cases, because there are many cases where there are opportunities to reduce the amounts of dust extracted from the process and still be within the maximum allowable concentration. So still be reducing the emissions to the operators very much, and linked to that, for example, also the ATEX zoning, and reduce the housekeeping. So really looking into the process makes a lot of sense here, because from there you will be able to identify what's the best approach here, and how can this be handled in the best way, and also in the long run in the most economical way, and making sure, of course, your systems are reliable over time. We want to have them working, of course, during startup and commissioning, but also after 5 or 10 years. So that's also where the balancing and the minimum fouling system design is a very important parameter. So I hope this gives you an overview of the approach, how we are looking at central dedusting systems, and I would like to give the word back to Bas.
Thank you so much, Martin. Really appreciated it. We have received several questions. We tried to limit this webinar within half an hour. So let's address one question. We have received question, it all feels quite tailor-made, sounds expensive. So yes, surely in the engineering we will spend time making it all tailor-made for the specific site, depending on the dust characteristics. But well, afterwards we will surely get the investment back, because we will use standard equipment if applicable, but also reuse existing equipment, and of course create added value concerning the safety all elements Martin mentioned. So creating a more safe and reliable environment with more uptime. So that's also very beneficial. And of course, keep in mind that the energy efficient and less waste, so less waste of product. Did I forget anything, Martin?
No.
Good. Oh, good. So we have received several more questions, but seeing the time, we will collect and share with you all. We will also share the presentation given, and of course share the link with the replay. So thank you so much for attending. Hopefully see you in our next webinar later this year, and well, see you soon.
Thank you very much.
Bye-bye.